In this video, we're going to go over the concept of vertical asymptotes and discontinuities. We need to understand this concept so we can start evaluating infinite limits. Vertical asymptotes and discontinuities are something that we learned in pre-calculus. You might have even had it in Algebra 2, but it's always good to refresh our memory on how to take a rational function and evaluate and see if you have any of these vertical asymptotes or discontinuities. So let's look at a couple of examples to refresh our memory. So we want to find any vertical asymptotes or discontinuities. So those are the directions. So for A, we're going to look at the function f of x equals 2x squared all over x squared minus 1. Now, in order to find any of these discontinuities or asymptotes, the first thing we need to do is we need to find the zeros and the poles. So to remind ourselves, a zero, the zeros, or any value that made the x value 0, okay? So, or the numerator 0. So any value of x that makes the numerator 0. So a pole is any value of x that makes the denominator 0. So let's first start off with our zeros. So our zeros would be 2x squared equals 0. Well, this basically makes x equals 0 and x equals 0. Easy enough. Now let's look at our poles. This particular one, we would have x squared minus 1 equals 0. So we gotta figure out if we can solve this. So I believe that's x minus 1 times x plus 1 equals 0. So we end up with x minus 1 equals 0, x plus 1 equals 0, so x equals 1, and x equals a negative 1. Now at this point, when we were sketching rational functions, we would determine if we had x-intercepts, vertical asymptotes, or at the time we would call it holes. And so we would compare the zeros and the poles. Now, because the zeros do not have a matching pole, these are both x-intercepts. We don't have to write that down because the question doesn't ask us to find that, but these would be x-intercepts. Because these poles do not have any associated zeros, that means these are both vertical asymptotes. So for this problem, we have vertical asymptotes. At x equals 1 and x equals a negative 1. And so that would be the answer to this. Let's try another example, just to make sure we understand it. Let's say we want to evaluate f of x equals x squared plus x minus 2 all over x squared minus x minus 6. Okay, so we want to see if there are any vertical asymptotes or discontinuities for this particular rational function. Alright, so we first start off with our zeros. x squared plus x minus 2 equals 0. So let's see, we can factor this. Minus 1 plus 2. So we end up with x equals 1 and x equals a negative 2. Now let's look for the poles. So we have x squared minus x minus 6 equals 0. Let's factor that. Let's see, minus 3 plus 2. And so we end up with x equals 3 and x equals a negative 2. Okay, so in this one, we have an x equals 3, but there's not an associated 0. So as up in here at the previous problem, we know that this is a vertical asymptote. This one, however, we do have a pole and a 0 that matches. So if you end up with a 0 and a pole that are the same, then this becomes a discontinuity. And actually, we call this a removable discontinuity. All right, so there's a good review of finding vertical asymptotes and removable discontinuities. One thing to note is last year in pre-calculus we called this a hole, not a discontinuity, but we have gotten to the point where we have to call it a removable discontinuity. But that's okay. So, but the idea is still the same. We find the zeros, we find the poles, and we compare those. And then, of course, if you have a pole with no associated 0, it's a vertical asymptote. And if you have a pole with an associated 0, that is a removable discontinuity.